This is my MAE 334 final project. As you can see, it is a guitar with a bunch of electronics attached to it. But what does it actually do? To answer that question, some background. In the 1960s, the Vox company produced a electronic guitar organ which took a Vox Continental organ and put it inside of a Vox Phantom guitar. As you can see by this schematic, there's a lot of complicated pieces inside of it, but principally fretting the metal string would connect it to a network of resistors in the neck, and depending on which fret was pressed would correspond to a note that the organ circuitry would produce, much like a keypress on a standard keyboard. As you can see, it's a pretty large and bulky instrument, and it required its own power supply and audio routing box. That would be the one on the right side. Interestingly, it has plenty of knobs, buttons, and switches that not only control the sound of the guitar, but it controls the sound of the organ and parameters for sequencers and percussive sounds on the organ. The guitar organ was designed by Dick Denny at Vox, and he can be seen here playing the guitar organ, as not only was he an engineer and a designer, he was also a musician. My project attempts to replicate the guitar organ, but using modern circuitry like op amps and transistors and some resistors and an Arduino board that registers the notes quite similarly, but will output MIDI rather than generate the tone itself. Here is a demonstration of the resistor contacts. As you can see, there is a bit of a latency and there is a jitteriness to the sound. That's a result of primitive coding and the analog digital converter not exactly liking the output that my circuitry delivers for registering the different resistances in the resistor chain. That can definitely be improved with better coding and a more carefully designed circuit. Up next is a demonstration of the open string buttons. Essentially, what the buttons do is they simulate being able to play an open string on the guitar. Because it's not being fretted, you wouldn't be able to contact a resistor to actuate it. So the way Vox got around this was by using a button, and so did I. Actually, making the guitar was really fun because I got to use a CNC machine for this process. The actual modeling of the fretboard was done in Fusion 360, and I used a parametric fretboard modeler from the website GrabCAD, which was super awesome and saved a lot of time and effort and was well done. Here you can see the CNC cutter milling the slots where the frets will fit in. As you can see, the actual end mill is extremely small. It's a 0.6 millimeter 23 thousandths PCB drilling end mill, and it really is a testament to how precise this machine is. Only 3 hours of semi-attended work, and the finished result speaks for itself. Here's a picture of it in the sun. Here's a better picture of it in the sun. The wood species I used is Purple Heart, and it's incredible what it looks like when cut. The string retainer is an LSR roller nut by Fender, and the screws that the fret dot markers are from a gutted Apple iMac. Here's a picture of the roller bridge and the tremolo arm, or the whammy bar, which remarkably you can do some dive bombs on there and it will actually stay in tune pretty decently well. I am genuinely surprised for how primitive this whole setup is. Here once again is a finished shot of the guitar. As you can see, it is in fact a 3-string guitar that is made of a Douglas fir 2x4 that I acquired from the machine shop. I made it in 5 hours and the results speak for themselves. It is quite primitive. In the next clip you will hear a sound sample of me attempting to be a Delta bluesman. I know. The instrument is actually surprisingly resonant and loud, considering it is a 2x4 with a bridge and tuners on it. But listen for yourself. In this clip, you'll see me playing harmonics and using the whammy bar. It's pretty loud. Thank you for watching.